Good afternoon, all of you. This is Dr. Chukka Santhaiah, Associate Professor, CS Department, Institute of Aeronautical Engineering, Hyderabad. Today's presentation is on machine learning concepts. Outline of the session is classification of machine learning, well-posed learning problems, designing a learning system. First, we discuss about the classification of machine learning. This classification of machine learning is also called types of machine learning. In this machine learning, three types of the learning mechanism is there. Three types: supervised learning, unsupervised learning, reinforcement learning. When you observe this figure, this one is machine learning. These are the subparts, means types of the machine learning: supervised learning, unsupervised learning, as well as reinforcement learning. What it is meaning? What is the meaning of supervised? What is the meaning of unsupervised? We discuss one by one. First one is supervised learning. Supervised learning is a type of machine learning method in which we provide sample labeled data to the machine, to the machine learning in order to train it. And on that basis, it predicts the output. The system creates a model using labeled data to understand the data sets and learn about each data. Once the training and process are done, then we test the model by providing a sample data to check whether it is predicting the expected output or not. The goal of supervised learning is to map input data with the output data. The supervised learning is based on supervision, and it is the same as when a student learns things in the supervision of the teacher. The example of the supervised learning is spam filter. Here, first category of the machine learning is supervised learning. The supervised learning is nothing but it is a one type of the machine learning or classification of the machine learning, and it provides some labeled data, means structured data, to the machine learning in order to train it. On that basis, it predicts the output. Means in the supervised learning, the name indicates somewhat supervised, means some supervision is required. So in this mechanism, in this learning, supervised learning, we are given some labeled data, means structured data. Some label means some sequence of the data. It has some proper data. So based on that input data, it is processed on that input data and predicts the output. Means we give some input as well as get the output. But the data is labeled as well as structured. Next, the system creates a model using labeled data to understand the data sets and learn about each data. Means it is labeled data and it is learns each and everything. Means it learns something about each data. Once the training and processing is completed, then we can check the data, whether the output data is matched with the input data or not. Next one. The main goal of the supervised learning is to map the input data with the output data. The main objective of the supervised learning is to map the input data with output data. Means what type of input data is here we are given, as well as what type of the output data we have get, based on some processing according to the supervised learning. Means here we have some awareness, means we know some idea about the input data as well as expected output data. Here supervised learning. Right. The supervised learning is based on supervision. Means the supervised learning mainly especially works under some supervision. And it is same as when the student learns things in the supervision of the teacher. The example of supervised learning is spam filtering. Means The machine can be used. The machine can be learn something under some supervision. Example is spam filtering. Means spam filtering is nothing but a email filtering. Means the machine can be automatically receive the mails from various resources or various persons or various databases. Whenever the mail comes from the various resources, automatically the machine can be analyzed. That mail is relevant to the advertisement, that mail is relevant to the personal or somewhat important. Means some supervision is there here itself. The machine can be observed internally. Means whenever the mail will comes, automatically it is relevant to the personal information, automatically move to the inbox or primary inbox. Or in case it may be a somewhat spam, it may be somewhat like a business or advertisement purpose, it simply move to the spam folder. Some classification is there. Means here you get the main object of supervised learning is to map the input to map the output with the input. Means we can get some mails. So that mail is relevant. For example, this mail maybe comes from the advertisement or maybe find some business oriented. It may be leads to the automatic analysis itself. It is relevant to the inbox or maybe primary inbox. So automatically the machine can be classified. Then it is filter. Means automatically important mails goes to the personal mail or unimportant data mails goes to the spam filter or spam folder. The supervised learning can be grouped further into two categories of the algorithms: classification as well as regression. Means the supervised learning is again we can divide into two classes, two types: classification as well as regression. Classification is nothing but we have some divided some classification. We take some input data like our student database, student roll number, student name, date of birth as well as gender. We can classify it. Whereas come to the regression, somewhat is continuously. Means we can assign some range from the 0 to 10, 11 to 20, 21 to 30, like that. Regress, continuous process. Next one. Second type of the machine learning is unsupervised learning. The unsupervised learning is a learning method in which machine learns without any supervision. Means the name indicates itself. Unsupervised. There is no need of any supervision about the unsupervised learning mechanism in machine learning. The training is provided to the machine with the set of the data that has not been labeled or classified or categorized. And the algorithms needs to be acted on that without any supervision. The goal of the supervised learning is to restructure the input data into new features or group of objects with similar patterns. That is about the unsupervised learning. Means the unsupervised learning is especially without supervision, you can learn something. So, unsupervised learning, you can give some data, unlabeled data, unstructured data, not labeled, not classified as well as not categorized. And the algorithm needs, means the supervised learning algorithm is needs. We are act on that without any supervision. The goal of the supervised learning is to restructure the input data. Means we are giving some unstructured data as well as unlabeled data, unclassified data, uncategorized data. But that algorithm will works on that unstructured or unlabeled or as well as uncategorized data. It converted into new features, group of objects, means similar patterns. We are given some different, means heterogeneous data. It is divided some groups based on the similarity of the data or based on the similarity of the objects. That is about the unsupervised learning. Means the unsupervised learning is especially the machine can learn without any supervision, as well as We are given some input data, we are given the message to the supervised learning, we are given the input data, we are given the input to the unlabeled as well as unstructured as unclassified data, uncategorized data to the machine. And the machine can be run unsupervised learning and restructure the data. Means again it is form. It is structured data is unstructured data is converted into restructured or maybe structured data. And then we can divide into some similar patterns as well, groups or patterns. That is about the unsupervised learning. In unsupervised learning, we don't have a predefined result. Means, whereas come to supervised, we have idea about the input data as well as expected output data. But here, there is no predefined result about the unsupervised learning. Means, the machine tries to find useful insights from the used amount of data. It can be further classified into two categories: algorithms, clustering as well as association. Means, it is machine tries to find the useful insights, use amount of data. Means we are given some use amount of data, we can find some similarities. We are clubbed into some. We are group some. Here similar objects will come to group as a some objects, some categories. And it is classified into two categories. Means it is divided into two categories. That is about the clustering as well as association. The clustering is nothing but there is a collection of unsimilar data, but some similarity is there. For example, you take some input data like it is somewhat give some graphical representation. We have some objects are there. We can take some x axis as well as x direction as well as y direction. You can represent simply. Right. Here is some input data. It is unstructured. Means there is no categorization. But whereas come to the unsupervised learning, this unstructured or maybe unlabeled or maybe uncategorized data is classified and converted into restructured and it is classified into some group of objects or maybe clusters. Means for example, we can take these are the similar type one cluster. Means it has some most of the objects are have some similarity. So they are comes under the one category or one cluster. That is single. Here this comes under the another cluster. For example, you can imagine. The remaining is comes under the another category as well as another cluster. Means whenever we can give the unlabeled data there itself into this unsupervised learning, it is converted into labeled or maybe it is converted into somewhat restructured data. Next, association. The association is nothing but dependency. If one is depends on the other one. Means for example, we can take some of the x input, x hypothesis as well as y hypothesis as well as z hypothesis. Means x hypothesis about the something, y hypothesis about the something as well as z hypothesis about the something. Whereas come to the dependent association means the x hypothesis maybe depends on y as well as the y hypothesis, the z hypothesis depends on the y. Sorry. The y hypothesis depends on the x hypothesis as well as the z hypothesis depends on the y. We can take some simple example about the software life cycle, software paradigms. I can give some example about the association, some class, some dependency. Whereas come to the waterfall model, here I mentioned only 4 steps for the easy understanding. First one is analyze. Second one is design. Third one is coding. And fourth one is testing. Whereas come to the waterfall model, there must be some dependencies there, some association there between these phases or these steps about the waterfall model. How it is association as well obviously defines. Whereas come to the analysis phase, Whenever we can complete the analysis phase, then only we can move to the second phase. That is about the designing. And then whenever we can complete the designing phase, then only we can move to the coding phase. After that, whenever we can complete the coding phase, then only we can move to the testing process. Testing phase. Means in this analysis as well as design and coding and testing is depends on each and every step. Means the second step is depends on the previous step. That is the first step. The third step is depends on the second step. Means if any drawback, is there any find, is there any mistake is raised, is there any error is raised, is there any analysis, the entire effects and that effects goes to the down steps, which is about the analysis, designing, coding as well as testing. Why? Because some association is there. So like that, the unsupervised learning is works. Right. Next one is third category of the machine learning is reinforcement learning. The reinforcement learning is a feedback-based learning method in which a learner agent gets a reward for each right action and gets a penalty for each wrong action. The agent learns automatically with these feedbacks and improves its performance. In reinforcement learning, the agent interacts with the environment and explores it. The goal of an agent is get most reward points and hence it improves its performance. The robotic dog, which automatically learns the movements from his arm, is an example about the reinforcement learning. The reinforcement learning is also called semi-supervised learning, and it may be used, especially the unsupervised learning. So reinforcement learning is mainly based works on based on the feedbacks learning method. Means, for example, we take some agent. Agent here is nothing but a somewhat system or robot. We can imagine, we can think. Means, your system can be learned something based on its actions. Means, the agent can be make some good action. Means, get some reward points. Reward means, it is about the positive. Or maybe get some positive results, or maybe positive feedback. It is repeat that same action again, feature also. In case means in case it may be get some penalty, means negative feedback. The machine cannot be do the same operation, cannot make same action again because it will get some penalty. Means negative feedback. So automatically the agent or the system or robot automatically stop that action and don't repeat again in case features. That is about the reinforcement working process. Right. The agent learns automatically with these feedbacks to improve its performance. Means whenever the agent gets some positive means reward points, automatically its improve, the performance improves. And is there a penalty? Means it's a negative. It leads to the decrease its performance. So finally, the reinforcement learning agent interacts with the environment and explores it. Means whenever it is interacting with the environment, means surroundings, it senses it. It is explored. It's about either positive or maybe negative reaction. The goal of the agent is to get the most reward points and hence it is improves its performance. Means here the goal of the main supervised learning is, in supervised learning agent is learns, improve its performance by getting more reward points, means more positive feedback. Automatically the first positive feedback is there, it is improves its performance. It indicates its performance. As well, the example about the robot reinforcement in learning is robotic dog. Means we can make something. It gets some positive result, first feedback, again it is do the same operation. It may get some negative, means penalty. It is stopped, don't repeat the same action again. That is thing about the reinforcement learning. So, up to now, we discussed about the supervised learning, unsupervised learning, as well as reinforcement learning. One means we discuss one by means we have some. Once again, means in supervised learning, supervision is required. Means it is works as under supervision, and we have some idea about the input data as well as expected output data. Whereas come to the unsupervised means there is no supervision. Only we are give the unlabeled data, unstructured data, and we get some restructured data. And it is works based on especially on only unlabeled data and the unstructured data. And it gets some information after finalizing about the, it is classified into some clusters or groups, similar objects or similar things are there in unsupervised learning. Whereas come to the reinforcement learning, the reinforcement learning is mainly works based on the feedback mechanism or feedback based learning method. Means it is works. We get the rewards, it is again repeat the action. It is get some penalty, it stop it. Means finally the supervised learning is basically works on supervised, as well as unsupervised learning is there is no supervision, as well as reinforcement learning is based on the feedback based learning. That is thing about that. Right. Whereas come to the supervised learning, is main object is we can map the output data with input. As well as whereas come to the unsupervised learning, we are mainly try to define the data, means the data may be converted into groups as well as similar objects as well as similar groups. And the main objective of the reinforcement learning is to improve the reward points, and automatically it improves the performance. Next concept is well-posted learning problems. The well-posted learning problems is nothing but related to the machine learning approaches. What is the meaning about the well-posted learning as well as what is the definition about the well-posted learning? We discuss. Means the purpose of the machine learning is we will define learning broadly to include any computer program that improves its performance at some task through experience, as well as it put more precisely. Means the main purpose of the machine learning is to machine can be learned automatically and improve its performance by making some actions, making some decisions. So what is the definition about the well-posted learning problems? A definition about the well-posted learning problems is nothing but a computer program said to be learned from experience E, means about the E, experience E, with respect to the some class of tasks, means T, and the performance measures by the P. If its performance at a task in T as measured by P with experience E. Right. The well-posted learning problem is depends based on three parameters. Means first about the experience, task as well as performance. Means the experience means the machine can be means perform some tasks. Means the machine can be make some actions, make some performance on some tasks. That performance is measured by the P and improve its experience E. Means the machine can be complete some tasks. It shows some shows some performance. From that performance, we can expect some experience. Means the machine can be perform some task. That performance measured by some P, and performance is increased. Performance is good, and it learns something. Means based on that, you get some experience. Means well-posed learning problem is mainly depends on the three keywords. That is about the experience, class of task, as well as performance measures. That is it. Means the computer program should be learn from the experience with respect to the some class of tasks and performance measure P. If its performance is at tasks in T as measured by P improves with experience. We discuss one by one what is the problems are there, what the features are there about the well learning problems. The computer program learns that to play a checkers game. Here we can take some checkers game example for this well posed problems. Checkers game. Computer program that learns to play a checkers game, might to improves its performance as measured by its ability to win at the class of tasks involving playing checkers games through the experience obtained by the playing games against itself. Means we are taking this example about this checkers well posed problems. We are take some example about the well posed. That's about the checkers game. We discuss one by one how we can get some experience. Right. In general, to have a well-defined learning problem, we must be identify the three features. Means we can learn something. As well, we can discuss about the well-posed problems. We require them based on some tasks as well as performance, as well as measure of performance, as well as experience. We require some three features as well, three basic requirements about it. We can make some tasks as well as we can measure some performance and we can get some experience. We require some three important features. The first one is to perform the task, we require class of tasks. To make some performance, the measure of the performance to be improved. As well as we require some source of experience. Means we got some experience. We must require some source. So we need some experience. We have some tasks. As well as when we can perform some tasks, automatically we can measure some performance. These are the three features are there in well-posed problems. Discuss one by one. We can take example one by one, then we discuss one. Right. First one is well-posed learning problem example. First problem is a checkers learning problem. Here task is playing a checkers game. Means a checkers learning problem is main task is play a checkers game with the opponent or with your friend or with the system. Performance measure. How we can measure the performance in a checkers game? Percent of games won against the opponents. Means we can measure some performance. How we are how many times are we win the game with the opponent? Based on that winning percentage, we can measure the performance. And where we can get some training experience. Means playing a practice games against itself. Here itself means the system can be itself. But when it comes to the human being, playing a checkers game against practice games with your friends or with your colleagues or with your neighbors. Means in this especially the checkers game, main task is to play a checkers game. And second one is measure how can measure the performance means performance P. The percentage means percentage of the winning ratio or winning chances with the opponents. How many times we can win the game? Means based on the performance, you can calculate it. And then we get some experience. We need some experience. Before we can take some competition, we need some experience. We need some practice. So for that practice, we require experience. We can try to play a game with your friends or yourself or with your colleagues. Means based on this, mainly in checkers playing game, main task is playing a checkers game. Performance measure is percent of the games. How many times you can win the game. And third one is experience. Source of the experience is we can play a game with your colleagues or with your friends. Right. We can specify many learning problems in this situation, in this fashion, such as learning the recognize handwritten words or learning to drive a robotic automatic automobile autonomously. Means we discuss about like these problems about the handwritten recognition problem as well as autonomous vehicle driving. Right. Next problem. Next well posted example is handwritten recognition problem. The main task is recognizing and classifying the handwritten words within the image. And performance measure means percent of words correctly classified. And training experience is a database of handwritten words with the given classification. Means in this second example about the handwritten problem, handwritten recognition learning problem. Main task is about this one is to identify or recognize the number of handwritten words are there within the image. For example, some image is there. How many handwritten words are there in the from image? That is about the main objective, main task about the handwritten recognition problem. First task is to recognize or identify the handwritten words from the image or within the given image. Percentage means performance measure. How can measure the performance? Percent of words correctly classified. Means we are classified the words. Means about the words are comes on the other side as well as figures are comes on the other side. Classification. Or maybe we can divide the some words is one side as well as images are one side from that given input image or input data. And training experience. How can the training experience? When we have training experience? Means a database of handwritten words with given classifications. Means it is classified the images. It is classified a good classification. Means you can store the classified data, images as well as words in a specific categories in specific intentions, in specific location, specific under some classification. Then only we discuss about the performance is measured. Training experience is concerned. Means it is classified correctly. Words as comes under the words category, image comes under the image category. Automatically, it gets some experience. Next one, third example. A robot driving learning problem. Means third one is a robot driving learning problem. Your main task is driving a car on a public place, public 4-lane highways using vision sensors. Means the robot can drive the car in 4 ways in the public place in the traffic conditions by using some sensors. That is the main task. Main here robot is there. The main robot task is to drive a car. Means to drive a car in public places. Public places or public locations. That is the main task about the driving and learning and robot driving problem. Means second one, performance. How can measure the performance? Average distance travelled by before an error. Means are judged by the human oversight. How we can measure a performance from the robot car driving? Means average distance is travelled within a given time or within a given time as well as safely without any issues. Means averaging a average time, average distance it is travelled. For example, we can take some of the 1 hour. Means 1 hour is 1 hour means 60 minutes. How many kilometers are travelled within a given time? Based on that, we can performance measure. Means, for example, you will give some time. Means about it is crossed about the nearly 70 kilometers. Our aim is to cover the within 60 minutes 70 kilometers. Or robot driving car. It may be reached within a 60 minutes, within 1 hour. It may be reached about 60 kilometers only. Means it is about some performance measure. Next, how can you get some training experience about the robot car? Means a sequence of images and steering commands recorded while observing the human driver. Means how it gets some training experience. Means whenever the robot can drive the car automatically, it observes the images. A number of images are observed within a duration. How many images are observed? How many images are captured by the sensors and calculated. Based on that is get some training experience. Means about the left side image, right side image, front images, back side images, so and so. This classified. So like that, based on this, we are measuring we get some training experience. Means the robo car is drive safely car without any accidents, without any issues. Then it is about the safety. Means so here we discuss about three problems. Well-posted learning problems. First one is checkers problem. In checkers problem, main task is to play checkers game. As well as performance measured by the percent of the winning ratio. And training experience is play a game by itself. And whereas come to the second one, means about the handwritten problem. Main task is to recognize and classify the handwritten words within a given image. And performance is training experience and performance measured by the perfect means percent of words correctly classified. How many words are correctly classified? And training experience is that classified the images or words is stored in the under same category of the words or images. That is about the handwritten recognition problem, learning problem. Second one, the third one is a robot driving learning problem. Means the main task about the learning problem, learning and training problem is nothing but mainly it is drive the car in four-way lines. Means about in traffic conditions. As well as performance means how much average distance is traveled in a given time or given duration without any errors, means without any accidents or without any problems, without any violation of the traffic rules. Based on that, we can measure the performance. And training experience, how it is getting some training experience, how many images or objects are recognized by while driving the car. About these neighbor cars, neighbor vehicles, or neighbor vehicles, things or objects. How many? Means number of objects, number of images, number of objects and number of images are captured by itself. Based on that, you get the more experience. These are the main three training examples, means well-posted learning problems. First example about the well-posted learning problem is playing a checkers game. Second one is a handwritten recognition learning problem. And third one is a robot driving learning problem. Whenever we discuss we are observe these three examples, a hidden fact is there about these three examples. The first one is playing a checkers game, person to person as well as machine to machine, or maybe person to machine. Means about the somewhat general one. Whereas come to the second example, handwritten recognition learning problem, means about somewhat research orientation problem. About the way, because in image processing we can identify some unstructured unstructured as well as unlabeled databases, images. From that undefined images or unlabeled images, we try to rectify, we try to get some information about that images, images or pictures, like archaeology departments. They are finding the past century ago images also, thousands years ago images also. By using some research, they are finding some mechanism about some duration, this image is related to some specific duration about some certain period, means some duration. That is about the research oriented. Whereas come to the third example, that is about the automatic robot driving self-car driving problem. Means about it is completely depends on the robot, means technology developed. First one is human involvement, second one is research involvement, and third one is advanced technology involvement. Well-posted problems we discuss about the three categories: person to person, research-oriented problem, as well as advanced technology problems. But whereas come to especially these three problems have some similarity about the learning the problems as well as get some experience and make some performance, make some further some tasks. Right? Means these are the three problems are there in three well-posted training problems are there in master learning. Next concept is designing a learning system. What is the meaning of learning system? As well as what is the main object of the learning system? To designing learning system is especially we are trying to design a system. That system is learning system. What is the main objective of the learning system? Or what is the main purpose of the to designing a learning system? Means, for example, you can design a system, learning system. That learning system is try to play a game, checkers game with world or participate a game in the tournament or maybe world champion tournament. Means we can try to implement a code or try to implement a program or try to apply, develop an application. That application must be face a real-time experience, real-time problem. Try to solve a real-time problem. In the real-time problem, we discuss. Means we learn something. We are trying to design a system, the learning system. We have some steps. Here 5 steps are there in the designing a learning system. The first one is choosing a training experience. And the second one is choosing target function. And third one is choosing representation of the target function. And fourth one is choosing function approximation. And last one is final designing of the learning system. Final step of the learning system. Means first we can designing a learning system, we require some training. Means we require some training means we need some training to participate in any competition. We require some training means some practice. From that practice, what the main purpose, what is the main objective of the or practice? And how we can represent that target function, how we can represent the target function about from that experience, from that training experience. And is there mistakes arise? Is there mistakes that happened? How we can rectify that mistakes by using approximation function algorithm. And finally, we can design a learning system in final step. Thank you, ma. We discuss about this learning system the next class, next session. Thank you. One all.
Like, share and subscribe. Hit the bell icon for more updates.